Just doing a select few problems from the Algebra 2 Regents. Which graph has imaginary roots? Now, here's what you gotta know. So let me actually do this. So hopefully by now, you know what the function y is equal to x squared looks like. It looks something like this. Notice how this graph right over here touches the y is equal to 1. So this right over here, this line right over here is y is equal to 1. Y is equal to 0. Notice how this quadratic equation right over here, this graph right over here touches the y is equal to 0 line, okay? And when the function basically touches the y is equal to 0 line, or you can also call this the x-axis, right? X-axis, many names for it, but when the function touches the x-axis, well, this right over here is called the root of the polynomial, or a root of the quadratic equation. Now, if you want imaginary roots, well, imaginary roots are when there's actually no kind of solution to this. Well, and for imaginary roots, well, in order for a polynomial to have imaginary roots, it actually does not touch this x-axis right over here. So the only answer that matches up with this is answer choice number 2. When this right over here is written in the form y to the n, what is the value of n? And justify your answer. So it seems like this is some sort of exponent property kind of problem, where you have to combine all of these y's or whatever into one single exponent, y to some exponent. Let's do this. So first of all, you need to know how to convert from radicals to exponents. So when you have some sort of radical, let's say it can be, let's say if we have the bth root So let's say if we have the xth root of y to the z power. Now you can convert this into an exponent. This is just going to be equal to y to the z over x power. For example, if you have, let's say, the square root of, let's say, 3 to the second power, and then this is the third root, so this is the third root of 3 to the second power, you can rewrite this as 3 to the 2 over 3 power, okay? So the thing that's inside the root is going to be on the top. The thing outside the root is going to be on the bottom. So we can do this for this right over here. We can say that this is going to turn into y to the 2/3 power, because, right, this thing goes on the top, and then the thing outside the root goes on the bottom. And remember, this is divided by 1, and it's going to be multiplied by y to the 4th power. So now, if we multiply these two things together, we have y to the 4th power divided by y to the 2/3 power. Now, whenever you have two exponents divided by each other, so kind of two exponential things divided by each other, and they have the same base, well, what you do is you keep the base, but you subtract the exponents. And that's what I'm going to do here. So this is actually going to evaluate 2, so this is going to be y to the 4 minus 2/3. Right? I keep the base, but all I do is just subtract the exponents. And this is going to be equal to y to the, okay, so 4 minus 2/3 is 3 1/3. And 3 1/3, let's just write it as 10/3. So this is the same thing as y to the 10 over 3. Now here's the big mistake people do. They just leave this as their answer, which is wrong. Because remember what the question is asking. Whenever you do Algebra 2 Regents or just any problem in general, you got to answer the question. You got to see what the question is asking you. In this case, we're trying to find out what is the value of n, and n represents our exponent, right? So in our final thing right over here, our exponent is 10 over 3. So n is equal to 10 over 3, and there's our answer. So always make sure to remember, to actually answer the question before, rushing over to the next question. Well, all right, so we have 2x equals 6 plus the square root, 2 times the square root of x minus 1. A common mistake people do is they immediately square both sides. So actually, this is an awful color, but okay. So immediately what some people do is they square both sides. They think, oh, if I square both sides, I'm going to get rid of this square root. But in fact, squaring both sides is actually going to make this even more complicated, because guess what? This right-hand side of the equation is 6 plus 2 times the square root of x minus 1 squared, meaning that if you actually multiply all of this out, right, it's going to be even more complicated, because, right, you have 6 plus 2 times the square root of x minus 1, and then it's multiplied by itself again, right, because it's squared. Now, in order to multiply these two things together, well, you're going to have to FOIL, right? You're going to have to FOIL these two things. And that's just going to make things a lot more complicated, because you're still going to end up with the square root. You can actually, maybe for a practice exercise, try to maybe FOIL this out yourself. You'll only see that the equation gets more and more complicated. Is you want to subtract 6 from both sides. So you get 2x minus 6 is equal to 2 times the square root of x minus 1. And now you square both sides, because you don't have another term on the right-hand side. So you're not gonna have to FOIL with the square root on the right-hand side of the equation. So whenever you have, in this case, whenever you have a times, let's say, b, and this is to, let's say, a c power, so a times b to the c power, this is going to be equal to a to the c power times b to the c power. So in this case, this is in the form, right, a times b to some power. So this is going to be equal to a to the second power times the square root of x minus 1 to the second power, right? Imagine if you're kind of doing the distributive property for the exponent. I know it's kind of weird, but imagine doing that. 2 to the second power is 4. And this square root right over here cancels out with this to the second power. So you just get 4 times x minus 1. Another common mistake people do is they actually don't put, so, right, we have 2 to the second power, which is 4, right? And then after that, we have the square root of x minus 1 to the second power, which, the square root and the exponent cancels out. And we said this is equal to x minus 1. Now, a common mistake people do is, remember, these two things are being multiplied with each other. So make sure to put them parentheses to indicate that you're multiplying this whole thing, this whole x minus 1 by this 4. Right, in the beginning of our equation, right, we're multiplying this 2 right over here by this whole thing, at this square root of x minus 1. So this is the same case what we have to do here, right? We have to multiply, in this case, this 4 by this whole thing, which is now it's x minus 1. On this left-hand side, we have 2x minus 6 squared. I'm just spare you the suffering of having to FOIL this out. You're going to get 4x squared minus 24x plus 36. Let's distribute the 4 to this x minus 1. So you just have 4x minus 4 on the right-hand side. If I add 4 to both sides, I'm just going to get 4x is equal to all of this stuff, and then plus 40, right? Because 36 plus 4 gives you 40. And if I subtract 4x from both sides, I get 4x squared minus 28x plus 40 is equal to 0. All right, so basically what I did was I just moved everything to one side. And that's what you usually do for quadratic equations, right? You want to move everything to one side. So, maybe you can use the quadratic formula, or maybe find some way to factor this. Now, in this case, we can actually see that all of our terms are right over here have a factor of 4, or they're divisible by 4, right? Because right over here, if I divide this whole equation by 4, my right-hand side doesn't change, right? Because 0 divided by 4 is still 0. But in this case, right, 4x squared divided by 4 is just going to be x squared. Negative 28x divided by 4 is just going to be 7x. And 40 divided by 4 is just going to be 10. So notice how all of these things are divisible by 4. Now this is just a simple factoring thing. We can factor this out to x minus 5 times x minus 2 is equal to 0. And we get that x is equal to 5, x is equal to 5, or 2. Now, maybe if you're in a rush, you can circle this answer and move on with your life. But just to make sure, always just, put these values back to the original equation and see what happens, okay? So let's just check our work to make sure we're correct. So we're going to have, our two answers are x is equal to 5 and x is equal to 2, right? So let's just plug in 5 in for x first and see what happens. So we have 2 times 5, which is 10, is equal to 6, plus 2 times the square root of 5 minus 1, which is 4. The square root of 4 is just going to be 2. 2 times 2 is 4. 6 plus 4 is 10. So 10 is equal to 10, which is true. So this right over here, this 5 as our answer, checks out. Now let's check for 2. So if I plug in 2 into my equation, I get 2 times 2 is equal to 6 plus 2 times the square root of 2 minus 1, which is just 1. And the square root of 1 is 1. So just going to be 6 plus 2. And 2 times 2 is 4. Wait, what the hell? Wait, 4 isn't equal to 8. Wait, what? So in fact, x is equal to 5 is a solution to my equation, but x is equal to 2 is not a solution to my equation. Whoa. And this right over here, this 2 right over here, this fake solution. So whenever you're doing a problem and you have a sort of fake solution, this is another term for this is an extraneous solution. Extraneous solution. And this occurs very commonly when you're dealing with, when you're having to square both sides. So whenever you're having to square both sides of an equation, always watch out for these fake solutions or these extraneous solutions, okay? Now, in the Algebra 2 Regents, you're gifted a graphing calculator. So you can actually check the answers on the graphing calculator. You don't even have to do this much work. You can say, okay, I have two equations, right? I had 2x, right? I had 2x here. And then I have 6 plus 2 times square root of x minus 1. So I have 6 plus 2 times the square root of x minus 1. And guess what? We get 5 as our answer. X is equal to 5. And that's the only answer right over here. Notice how at x is equal to 2, right? The graphs don't intersect. So there is actually no solution at x is equal to 2, right? Right? These two graphs don't intersect. Robert is buying a car that costs $22,000. After a down payment of $4,000, he borrows a remainder from a bank, a 6-year loan at 6.24% annual interest rate. The following formula can be used to calculate his monthly loan payment. And we have whatever this is. Robert's monthly payment will be, and then blank. All right, so we know that our monthly payment is going to be P times I. So in this case, P is the loan amount. Now, what is our loan amount? Well, the loan amount is just going to be the remainder that he borrows from the bank. All right, so when you don't have enough money to actually afford something, you're going to borrow kind of the remainder from a bank, and you're going to kind of take out a loan, right? And you're kind of slowly going to pay back the money over time. So if you have if you have like a house that costs like $10,000, well, you can first off, initially you can pay $4,000. So you still have $6,000 to pay. And then for the $6,000, you can pay it back in, let's say, 10 years. So after 10 years, you can slowly pay back this $6,000 a little at a time. Okay. So when you don't have enough money, maybe in the present, well, you can, take out this loan and, pay it back over a longer period of time. Now, P is going to be the loan amount. So in this case, he is loaning $18,000, right? Because the car costs $22,000. He initially pays $4,000. So what does he have to pay left? What's left to pay? $18,000. This is going to be multiplied by I, which is monthly interest rate. Now we know that 6.24% represents the annual interest rate, right? 6.24 represents the annual interest rate. And annual is a fancy term for yearly, right? Now, if I want to convert from years to months, I divide by 12, right? I divide by 12. So if I want to convert from the yearly interest rate to the monthly interest rate, I'll just divide this by 12, right? So 6.24%, and then I divide it by 12, I'm going to get 0.0052. 0.0052. And this is going to be divided by 1 minus 1 plus our monthly interest rate, which we said is this. And then this is going to be to the negative t power. Now, t represents the time in months. Now, we know that the time that passes is 6 years, but we want the time in months. So 6 years is the same thing as 72 months. To convert from years to months, just multiply by 12. So this is going to be to the negative 72 power. Now, all that's left to do is just plug this into the calculator, and we should get our answer. I know that plugging the numerator into my calculator, so if I plug in my numerator into my calculator, I get 93.6. Now, if I plug in the denominator into my calculator, this can get around 0.311, and then it goes on. Okay? Now, make sure that you always round at the end of your answer. So right over here, I have 93.6, and I have this long answer. It might be tempting at first to round to the nearest tenth or to the nearest hundredth, but I recommend doing all the calculations first, and then after that, at the end, maybe rounding. Given tangent of theta is equal to negative 4 over 3, where theta is in between pi over 2 less than pi, what is the value of secant of theta? All I'm going to do right now is I'm going to draw out this angle. So this is saying that whatever angle that I have, let's just call this theta, it's going to be in between pi over 2 and pi. So it's going to be in between, it's going to be greater than pi over 2, but it's going to be less than pi. So it's going to be located somewhere in the second quadrant. And notice how in the second quadrant, our angle right over here, right? Our angle right over here, it's going to have a negative x value, and it has a positive y value. This should look very familiar to you from kind of the unit circle, all right? Now, let me just draw an altitude downwards. So let's just draw an altitude downwards, and this creates a right angle. Now, to do this problem, you need to know what this angle, that's this acute angle that's formed from this ray that I've drawn and the x-axis, all right? So reference angles are always an acute angle. Now, we're given that tan of theta is equal to negative 4 over 3. So all I'm going to actually do is I can say that this side right over here is 4, and this side right over here is negative 3. And so that means that tangent of my angle, of my reference angle that I've created, is going to be equal to 4 over negative 3. All right. Now, we want to know what secant of theta is equal to. Now, secant of theta is equal to 1 over cosine of theta. So we need to find out what cosine of theta is equal to before finding out what secant of theta is equal to. Now, in this case, right over here, we know cosine is equal to adjacent over hypotenuse. So in this case, cosine of our angle x right over here is going to be our adjacent side, which is negative 3, over our hypotenuse, which hopefully you can recognize this is a 3, 4, 5 triangle. Or you could just do the workout yourself, right? Negative 3 squared plus 4 squared is equal to, let's say if we didn't know this side was 5, let's say this is x squared. You would get 25 is equal to x squared, and you would get that x is equal to 5. Whenever you're solving for this hypotenuse, right, it's always going to be positive. It represents some sort of distance from the origin. All right, so we're going to get x is equal to 5. So then cosine is going to be negative 3 over 5. And we know secant is 1 over cosine. So secant is 1 divided by negative 3 over 5. So we can flip this fraction. So we can say this is 1 times 5 over negative 3. And 5 over negative 3 is going to be our answer. All right. Final question. To solve the equation, whatever this is, Jones' first step is to multiply both sides by the least common denominator. Which statement is true? So this is an extraneous solution, this are extraneous solutions, there are no extraneous solutions. So remember, extraneous solutions are basically fake solutions that, occur when you're trying to solve this problem. Now, immediately, some people will notice that x is in the denominator, and we know that the denominator of this equation can't be negative, right? So x actually cannot be equal to negative 7, and it can't be equal to 7, because if you plug negative 7 into this denominator, it's going to make it 0. If you plug in 7 into this denominator, it's going to make it 0. So x can't be equal to these two values. And these are something known as restrictions. Restrictions are basically the values of x that it can't be equal to. Okay? Now, let's actually solve this equation. So, in this case, we have 7 divided by x plus 7, and we have plus 4x divided by x minus 7 equals 3x plus 7 divided by x minus 7. Let's try to get a common denominator on this. So I'm going to multiply the top and the bottom. I'm going to multiply the top and the bottom of the first part by x minus 7. For the second part of our equation, I'm going to multiply the top and the bottom by x plus 7. X plus 7. And for the third equation, I'm going to multiply the top and the bottom by x plus 7. The reason for this is, look at the denominator now. Now, our common denominator is x minus 7 times x plus 7, right? Whenever you're trying to find out the common denominator of, in this case, this is like some sort of rational equation. Well, it's usually, most of the time, it's just going to be these two denominators multiplied out together. So in this case, our common denominator is x plus 7 times x minus 7. So if we want this denominator right over here to look like our common denominator, which is x plus 7 times x minus 7, right? You have to multiply the top and the bottom of this first part by x minus 7, right? To get it to the same thing. You would multiply this part of the equation by x plus 7 because, that's how you get the common denominator. And you would have to multiply this last part by x plus 7 on the top and the bottom so that you get the common denominator. So in this case, I'm going to have, so 7 times, this is going to be 7x minus 49. I have x plus 7 times 4x, so I'm going to have 4x squared plus 28x. And this is going to be equal to 3x plus 7 times x plus 7, which is going to be equal to 3x squared plus, so this is 28x plus 49. And remember, now that we have a common denominator, right, all of this is going to be divided by x minus 7 times x plus 7. And then the denominator in this equation right over here is x minus 7 times x plus 7, right? All right, now we know the denominators are equal to each other, so let's just set the numerators equal to each other. So our new equation is just going to be this, right? Because we know the denominators have to be equal to each other, so the numerators have to be equal to each other, right? Now, this 28x and this 28x cancels out. So if I just move everything to the opposite side, I subtract 49 on both sides, I subtract 3x squared from both sides, I'm going to get x squared plus 7x minus 98 is going to be equal to 0. And if you factor this, you're going to get x plus 14 times x minus 7 is equal to 0. All right. So either x is equal to 7 or is equal to negative 14. But however, we said how x cannot be equal to 7, right? X can't be equal to 7. So this 7 is an extraneous solution. So sometimes an extraneous solution is extraneous if you plug it into our equation and it doesn't work. However, another way that kind of a solution can be extraneous is if it matches your restrictions. So your restrictions just simply puts out what can x be equal to. But when our extraneous or when a solution matches this restriction, then it's considered an extraneous solution because we know that x can't be that value, right? Now, can x be equal to negative 14? Well, let's plug it into our equation to see if it works. So we have 7 divided by negative 7, right? Because if you plug in negative 14 here, you can do the math there. But you have negative 14 minus 7, so negative 21 is equal to 3 times negative 14, negative 42 plus 7 times negative 21. So this is just going to be equal to negative 1. And this is negative 42 divided by negative 21, so this is going to be plus 2. And then you're going to have and 3 times negative 14 is going to be negative 42 plus 7 divided by negative 21. All right, now 7 divided by negative 7 is going to be negative 1. We have plus 4 times negative 14 is negative 56 divided by negative 21. Two negatives make a positive. And then we have negative 40, this is going to be negative 35 over negative 2. So you're just going to be left with 35 over 2. I mean, wait, sorry, 35 over 21. Not bad. 35 over 21, right? Because if you plug in negative 14 in for x here, you get negative 14 minus 7, or just negative 21. And if you actually just do this, you can rewrite 1 as negative 21 over 21. So combine the fractions together. 56 minus 21 is 35. And these two things are equal to each other. So negative 14 works for a solution. So the only answer that makes sense is 7 is an extraneous solution, because that's the answer, that's the fake answer that we got when we were solving the problem.